All right, folks. Good evening, everybody. It's Tomb Raider 582. I'm at the multiverse, and I want to take you to the James Webb Space Telescope. Yes, indeed. Aha. Wow. Where shall we start? This exploration lobby. Multiverse, James Webb Gallery. Here we go. James Webb Gallery, left or right? Let's start left.
The observatory comprises two main parts, the optical telescope element, and the integrated science instrument module. The instrument module is made up of components such as a mid-infrared instrument, a near-infrared spectrograph, and the sunshield. Interestingly, the telescope doesn't have any cameras on board, so engineers are unable to see the telescope itself. This is
Mm.
partly because the telescope operates in the complete dark, so any camera would need a flashbulb that could interfere with the telescope's ultra-sensitive mirrors and detectors. Also, it would be incredibly difficult to make a camera that would work in the cryogenic temperatures on the cold side of the sunshield. Any heating system would cause Webb to accidentally study the heat signature of the cables, rather than the signature of the universe. Webb has a giant, tennis court-sized sunshield. The sunshield is critical, because the infrared cameras and instruments must be kept very cold, and out of the sun's heat and light. The optical telescope element, and the integrated science instrument module.
Let's try this again.
The sunshield is made of 5 layers of an insulating film, called kapton. Each layer is as thin as a human hair, and is coated with a reflective metal.
Mm.
During orbit, the observatory will be angled, so that the sun will only ever directly shine on layer 1, no matter which way the telescope is pointed. By having 5 layers to the sunshield, each successive one is cooler than the one below. One single thick layer just wouldn't be as good.
Wow. Let's see. Primary mirror, Hubble mirror.
One of the main innovative technologies developed for Webb was the primary mirror, made of 18 separate segments, that unfolded and adjusted to shape after launch.
Mm.
Webb needed to have an unfolding mirror, because the mirror is so large, that it otherwise could not have fitted in the launch compartment of the rocket. The mirror has to be large, in order to capture the faint light from the first star-forming regions, and to see very small details at infrared wavelengths.
Mm.
The mirror itself is made of small hexagonal panels. The
Mm-hmm.
hexagonal shape made it possible to build a segmented mirror without gaps, and that was roughly circular in shape.
Okay. Oh, check this out. Birth of stars.
These towering tendrils of cosmic dust and gas sit at the heart of the Eagle Nebula. They have been named pillars of creation and are one of the most famous birthplaces for stars. Stars are born in clouds of gas, and until they are powerful enough to blow away that gas, it is very hard to see inside.
Mm.
The infrared instruments on James Webb will be able to look through the gas, and see stars that are being born in these cocoons. This image features the spiral galaxy NGC 691, imaged in fantastic detail by Hubble. Looking at galaxies is a useful way to see how matter is organized on gigantic scales, which in turn gives us hints as to how the universe evolved. The spiral and elliptical galaxies we see today actually evolved from different shapes over billions of years, and one of Webb's goals is to look back at the earliest galaxies to better understand that evolution.
Mm-hmm.
This photo taken by Hubble shows the furthest galaxy ever observed in the universe, seen as it was, 13.4 billion years in the past, just 400 million years after the Big Bang.
Wow.
The universe is very big. That's an understatement. This means that light from events that happened right at the birth of the universe is only just reaching us today. Using telescopes such as James Webb, we can capture images of these events and learn more about the origins of the universe. Webb will be able to see what the universe looked like around 250 million years after the Big Bang, when the first stars and galaxies started to form.
Planets and origins of life. Exoplanets.
This image taken by the Spitzer telescope shows the location of a star just off the W shape of the Cassiopeia constellation. This star is the nearest one to Earth that has exoplanets, but none of which are habitable. An exoplanet is a planet outside of our solar system. James Webb's powerful sensors will be able to peer at these planets in more depth, and in some cases, it will take images of their atmospheres. Understanding the atmospheres and the conditions in which exoplanets formed could help scientists better predict if certain planets are habitable or not. This image taken by the Spitzer telescope shows the location of a star just off the W shape of the Cassiopeia constellation. This star is the nearest one to Earth that has exoplanets, but none of which are habitable.
Gold-coated mirror. Yes.
Webb's mirrors are coated with gold to optimize them for infrared light. Gold reflects blue light very poorly, but it reflects red and infrared light extremely well. This is why it looks the color that it does to our eyes. The gold used to coat the mirrors on the telescope is about same mass as a golf ball, or 48.25 grams. The thickness of the gold coating is 1/10 billionth of a meter, or 1,000 angstroms, spread over a surface area of 25 meters squared. The gold is overcoated with a thin layer of silicon dioxide, i.e. glass, that protects the gold.
Here we go. Micrometeorite damage and ripstops.
The membrane material used to make the huge sunshield is tough, but if it gets a small tear or hole, for example from a micrometeorite, the hole could become much larger. Each layer of the sunshield has therefore been designed and built in a grid pattern of ripstops. Any small tear can only extend as far as the closest ripstop, and the rest of the membrane will stay intact. The 18 gold-plated hexagonal mirrors are made of beryllium, a relatively rare metal that is 1/3 lighter than aluminum, but has 6 times the specific stiffness of steel. Beryllium is a gray, brittle metal, with an atomic number of 4, and a high strength per unit weight. Many parts of supersonic aircraft are made of beryllium alloys. The specific advantages to Webb are beryllium's lightweight, stiffness, and its stability at very cold temperatures. The beryllium used for the telescope was obtained from the area shown here, the Spore Mountain mining site, in Utah.
Wow.
In the rocky ground around Spore Mountain, Most beryllium is found within minerals, such as bertrandite and beryl, that formed 25 million years ago, when lava cooled after a volcanic eruption.
How big is Webb? Holy moly.
Webb's sunshield is about 22 meters by 12 meters large, which is about half as big as a 737 aircraft, or the size of a tennis court.
Size of a tennis court. Wow.
However, the most important size when talking about a telescope is the diameter of the primary mirror. For Webb, this is approximately 6.5 meters. This is about 2.75 times larger in diameter than Hubble, and about 6 times larger in area.
Oh, let's check out the James Webb Gallery. Absolutely. It launched in December 2021. James Webb is the largest optical telescope in space. This gallery exhibits its first images captured from January through September 2022. Wow, look at that. This is located in the Carina Sagittarius arm of the Milky Way, distance 7,600 light years away. Whew. Phantom Galaxy, spiral galaxy in the constellation Pisces. Distance 32 million light years. Phantom Galaxy contains about 100 billion stars. Distance 32 million light years. Wow, so many stars. My goodness. Wow. Galaxy cluster. This image covers a patch of sky the size of a grain of sand, held at arm's length. Wow, distance 4.2 billion light years. This is remarkable. Let's start at the left. Tarantula Nebula, located in the large Magellanic Cloud, distance 170,000 light years. Wow. Tarantula Nebula. Tarantula Nebula NGC 2770. Radius 931 light years. Distance 170,000 light years. Interacting galaxies, galaxy pair VV191. White elliptical galaxy left and spiral galaxy right. Distance 715 million light years. Shoo. Neptune's rings and 6 moons. Visible moons: Galatea, Naiad, Thalassa, Despina, Proteus, and Larissa. Distance 2.7 billion miles. Voyager, Hubble, Webb. 3 views of Neptune. Neptune appears blue because of the methane in its atmosphere. Distance 2.7 billion miles. Okay, this one was taken by Voyager 2 in 89. This one by the Hubble in 2021, and this one by the Webb in 2022. Neptune and its largest moon, Triton. Triton uniquely orbits in the direction opposite to its planet rotation. Distance 2.7 billion miles. Jupiter, September 4, 2021. Jupiter measures about 89,500 miles along its equator. Distance 376 million miles. Jupiter with its rings and moons. The bright spot to the left is the moon Adrastea, 777 times smaller than Earth. Wow. Distance 365 million miles. Cartwheel Galaxy. Above taken by the Hubble, below by the Webb. A lenticular ring galaxy. Distance 500 million light years. Cartwheel Galaxy, caused by a collision between a large spiral galaxy and a smaller galaxy. The distance is 500 million light years. Cartwheel Galaxy, the Chandra Observatory detects X-ray emissions from very hot regions. Distance 500 million light years. DART colliding with Dimorphos. DART slammed into Dimorphos in an attempt to redirect the moonlet's orbit. Distance 6.8 million miles. Dimorphos. DART collision with Dimorphos. The two telescopes simultaneously capture the same target in the cosmos. Huh. Distance 6.8 million miles. Galaxy IC 5332. Hubble and Webb. A spiral galaxy 1/3 smaller than the Milky Way, distance 30 million light years. I seem to like more the Hubble images. Stephan's Quintet, located in the Pegasus constellation, distance 290 million light years. Stephan's Quintet, discovered in 1877 by Edward Stephan, distance 290 million light years. Stephan's Quintet, a visual grouping of 5 galaxies. Distance 290 million light years. It is so pretty. Stephan's Quintet. Southern Ring, planetary nebula, dust and gas ejected from a dying star. Distance 2,500 light years. Southern Ring, planetary nebula, located in the Vela constellation. Distance 2,500 light years. Hey, we've seen the Hubble Gallery. All right, folks, this is all for now. I'm getting tired. It's been a pleasure to share this gem with all of you. And please subscribe to my YouTube channel at Tomb Raider 582, or you can follow me on X at Tomb Raider 75. Good night.